H2K Infosys provides world-class online IT training, staffing and software testing solutions to customers worldwide. H2K Infosys supports 100% job-oriented training, hands-on project work, cloud test lab, resume preparation and review, mock interviews, robust syllabus. One-time pay, lifetime access to live classes and videos. H2K Infosys has won the trust of thousands of students worldwide. For free demo class, visit h2kinfosys.com.
So these are the three classes or three programs that I will write independently, and I will club all these things into a single jar file, and that jar file is my program.jar file. Now I will give this program.jar file as an input to my job tracker, right? Because job tracker is the guy, or he is the master who will process all the jar files, right? Okay, now let's imagine that I have 3 data nodes in my cluster. And on each data node, I will be running a task tracker, right? So imagine that there is task tracker running on this machine. What is this, man? Okay, let me write it. No other option. Now each machine along it has some data as well, because the data node will contain, each machine will contain a data node and also a task tracker, right? So the data node will hold the actual data as well. So imagine that this is my actual data. And what happens is, once I create a jar file and I submit it to the job tracker will copy this jar file to each of these data nodes. Okay. So it has copied the jar file here to all my data nodes. Okay, so also think that this is also a jar file and this is also a jar file. So when I had written my program and submitted it, my jar file got deployed everywhere. That means on all the machines. Now what is the first step? Then my first map phase starts, right? So when the map phase is started on the first machine, when the map phase got started working on this particular jar file, from this jar file it will only pull the contents of my mapper itself. So my task tracker will pull only the contents of map, and then it will give, or it will process it. And imagine that this is my mapper output. Let me give some other. So imagine that this is my mapper output. Now again, the same another part of the program has been working on this particular data, and it has pulled the same jar file from here for the map phase to run, and it will generate another output. So if you compare it with our cards example, here it will create Where is it? Right. So on my first flapper, these are the outputs: club 1, heart 1, spade 1, again club 1, diamond 1. So this is my output: club 1, heart 1, spade 1, club 1. And again on the second machine, this is my output, map output: spade 1, diamond 1, club 1, club 1, club 1. So this is again my mapper output. And same thing again happens here. So now all these will be sent to, every task tracker will give a heartbeat to job tracker saying that, okay, my map tasks have been finished and we can proceed with the next one. So job tracker will see that every machine have been processed their own map tasks that were assigned to their task tracker, and once it gets all the acknowledgements from the task tracker, it will say to execute the mapper phase as well. But internally, in the inbuilt our structure, what happens is, first the job tracker will decide like on which machine my reducer has to run, because it is having 3 machines that were running right now. But still the reducer cannot run on all the 3 machines because the reducer itself is the aggregation of all the 3 machines output, right? So it can run only on one machine. Now once it gets the acknowledgement, job tracker will decide and it will say like on which machine my reducer has to run. So suppose let's imagine like job tracker has decided to take machine 2 as a reducer machine. So it has passed a command stating, okay, run the reducer step on machine 2. So it will pass that command to this task tracker. And now once that command is passed, what happens is the mapper output of each of the machine will be copied into this machine. So all these 3 outputs. So this is actually my intermediate data, right? So the intermediate data have been moved into this particular machine 2, and once the reducer phase is done, it will generate the final output, which is the required one for the client. So this is the final output which is required for the client, right? And this final output, once it has been produced, the task tracker will give an acknowledgement to job tracker stating, okay, I am done with my job, you have given me to do a mapper task. So I had got that jar file information from the jar file which you had thrown to me, so and I have processed it and I had generated this output. So now the job tracker will take this output and give it back to the end user. So this is what happens internally on the machines. So this is how the job trackers and task trackers will talk to each other and process each of the file. So anyone have any questions on this? Or is everybody fine with this?
Raji, I have a question.
Yeah.
So you were talking about splits, right? So where does the split happen? So once the job tracker knows, okay, this is my jar file that that the user wants to run, and this is my data. So does the job tracker create the splits based on the data, or?
No, the input splits were not created by the job tracker. There is something called as input format. So it will generate the actual input splits. But this job tracker will read those input splits only. It doesn't read the blocks. Job tracker will or can understand only the input splits. So there is something called as input format where it will generate the input splits for each of the blocks.
So input format is part of the mapper.
It is part of our framework.
Okay, so it happens when you run the mapper class, or?
No, before my jar file is given to my job tracker, all this will happen behind. So once the okay, fine. Akshay, you are not able to hear my voice or anything else? Okay, I don't get it. Guys, hope you are able to hear me properly. Okay, just let me know if that's not the case. But now we had, let me explain you one more thing as well. Initially, when you remember, during the introduction of our big data, we have discussed about one topic called as data locality, right? So can anyone give me or throw me a light on what is data locality? Hopefully everyone has heard this word, but anyone can guess it?
Does it mean data residing in the same server or same rack?
Not exactly. What is the difference between the Hadoop? Okay, fine, Arjun. Okay, just let me explain. Okay, I mean you are a bit closer to those things, but let me explain you in a better way or in a better form. Okay, so the difference between Hadoop and another technologies is, in any of your distributed systems, what we do is we will move the data to that particular machine to get processed. But in Hadoop, what we are doing is the process has been sent to machine where the data is being resided, right? So that is the only beauty of Hadoop, and that is where we are fetching all this or advantages, right? Because the data is very huge and we are not able to move this data to different machines. That is the reason in Hadoop we are moving the process itself instead of the data. If you see that old example, you are moving the jar file to where the data is actually available, because the data is available on that data node and you are moving your jar files, right? But the data is not moving to that particular machine where your task have been processed. Do you agree that? Okay, cool. So that is what the data locality says about. So let's imagine this is, I'm having 3 racks in my cluster. Rack 1, rack 2, rack 3. And in each of my rack, I will have multiple machines, right? Everyone agrees with me, right? Don't give a shock like what is this? Okay, so each one is a machine here. Okay. And imagine that my data is available here. So first job tracker will see that, okay, machine 1 is holding this particular data where I need to run this process. So job tracker will try its best to move its map task to where the data is available. So it will try to run my map task here itself. On this machine itself, it will try to run my map task because my data is available on this machine. So it is very convenient for me to run where the data is available such that I can assign my map tasks. So this is the best way that it will try for. But if that is not the case, and imagine that I'm having the data on this machine, but still all the maps or all the task trackers that were running on this machine were totally busy and they were not able to take a new jar program, right? Okay, everything is doing their job and none of the task tracker is ready to accept it. In that case, it will try its best to assign a task tracker to run on this data on the same rack. So it will try to see that if any task tracker is available on the same rack such that it can run on this data. So if it thinks like, okay, this particular task tracker on machine 3 of rack 2 is free and it is able to process the data, it will just copy this data to this machine and it will assign this map task to run it. And in the worst case, the data is available here and all the machines on this rack itself were busy. In the sense, all the task trackers were running completely busy on this rack 3. Then the only case it can do is it can assign a task tracker that is running on another rack. So it will feel like, okay, some task tracker on rack 2 on machine 4 is free and it is able to run that data. So it will move this particular data to here. Okay, let me keep like this. So this is the worst case. So in between the racks. So the best case is to run on the data that is available on the same machine, and the second best case is to run on the data that is available on the same rack. I mean, to assign a task tracker such that it is available on the same rack itself. And the third worst case is it will try to shift the data between the racks of the same cluster. Okay, so that is what the data locality concept is about. It will try its best to have less concentration on the network traffic. So anyone have questions on these things, guys? Just let me know. We will try to wind it up for today, and we can discuss much more. Probably we can take one example to do tomorrow, and we can see a hands-on on that, how the Mapreduce is working, what are the things that you will find it on your web interface and on the terminal as well, how you will write a program to do some calculation using our Mapreduce, how it look like, what are the programs that we write. Because as of now we had seen like we will be running a mapper program, a reducer program, and also some main program. So we will discuss what each of it will contain and what each of the program logic has tomorrow. So for right now we will wind up with this data and with this information. Just do let me know if you have any questions. Okay, fine guys. Tomorrow is a Saturday for me, so hopefully if everybody is fine to meet at 7:30 AM IST, then we can have a class tomorrow. So guys, is it okay for you? 7:30 AM IST. So probably I think it would be 10 PM for you. Yes. Yes, Arjun. So is it fine with everyone? So can we go ahead with tomorrow's class? Sure. Okay. Thank you all. Thank you for joining. So let's see and hands-on on a single program tomorrow. Okay. Thank you guys. Bye-bye. Have a good night.